right, so we are going to go over the rhombus page. Again, it could be helpful to have the facts that you have written down about rhombuses in front of you. I also just included a couple reminders here. For a rhombus, the diagonals intersect to form right angles, so I just took the liberty of filling all those in. Diagonals bisect the angles, so all of these angles here will be bisected by the diagonal, so that will certainly help. All the sides are equal, so again, I filled in all the sides already. And just like a little fun fact here, like a reminder for you, a rhombus is made up of like two isosceles triangles, okay? So that sometimes helps me just remember or like just visualize different things within a rhombus. So here we go. Let's fill in all the possible information. Are you ready? Okay. All right. So number one, because the diagonals bisect the angles, I've got 40 degrees here. Boom. Okay. Now, because I know that all these angles are 90 degrees, I'm going to be able to fill in all these other angles like of the triangle. So this is going to be 50, and that's 50 because they're bisected. Again, these are 50 and 50, and then this is 40 and 40. Okay. Now, what helps me sometimes like just remember the angles is when I think about an isosceles triangle. An isosceles triangle has two sides that are congruent and then two angles that are congruent. So if you're picturing this big triangle here, and these two sides are, both the same, that means these two angles have to be the same. And, vice versa for these guys. And then if you would picture this large triangle here, this isosceles triangle, again, these sides are congruent, so these angles have to be congruent. So that's just a way to make sure that you're filling stuff in correctly. Okay, and next problem, number 2. Now I filled in the 13. If this is 5, that means this is also 5. Oh, and I did forget to mention at the beginning, like everything that's true about a parallelogram is also true about a rhombus because a rhombus is a parallelogram. All right, now these right angles allow us to find the measure of this diagonal right here because I have a right triangle. And what can you do with right triangles? I hope you all said it in your houses or wherever you're watching this video. Pythagorean theorem, right? So you can set it up. 5 squared plus x squared equals 13 squared. This is the right angle. So the hypotenuse is across from the right angle. So that goes in where the C would be. So when you do the math, you're going to get 12 for your x. So 12 and 12. And I believe that's everything. We weren't given any of these angles, so we can't fill them in. We don't know what they are. Okay. For number 3. Ooh, 3 is a doozy. You should pause the video and try number 3 if you haven't already. So you've paused it, you've tried it. Let's see how much you figured out. So we know this is 30. Let's start with the easy stuff. And opposite angles are congruent, so 30 and 30, right? Also alternate interior angles. Okay, now that's 90, so this is a 60-degree angle. 60, 60, 60, 60. All right, now if you did the review in the enrichment geometry, and you remember from our special right triangles unit, what do we have here? A 30, 60, 90 triangle, which is a special right triangle. So even though I only have one side, I can find my other two sides. So this is a pretty easy triangle here to figure out if it would help you if you can't visualize it inside the rhombus. Oh dear. Oh, okay, well I'm in pen, so I'm going to have to ignore that. But the 12 is the hypotenuse. So to go from the hypotenuse to the short leg, you'll remember we get a 30, 60, 90 triangle from cutting an equilateral triangle in half. So you just cut the 12 in half to get 6 to get the short leg. So that means this is 6, and that's 6. Now to go from the short leg to the long leg, you're going to multiply by root 3. So this is 6 root 3, and that is 6 root 3. Look at that. Good stuff, huh? All this stuff coming together. I love it. Okay, number 4. So we know this whole thing is 78 degrees. that means this whole thing is 78, but that also means these angles are both 39. 39, 39. We know this is 9er, and that's 9. Because this is 78, and this is a parallelogram, I know that these two angles have to add up to 180, meaning this whole angle is 102 degrees, like from here to here. So, oops, these are both 51. This kind of gets messy when you start filling everything in, but this would also be 51 degrees. And I think that's everything we can fill in with that rhombus. All right, great. Let's move on to number 5. Oh, we got to draw our own. It's kind of hard to draw a rhombus. I'm so nervous. The pressure's on. Okay, so it's rhombus called Rom. Okay. So here we go. Oh, crap. I already made it too big. Okay, that is almost perfect. I'm kind of proud of myself right now. All right, so R-H-O-M. Again, make sure you fill the letters in an order. And the diagonals. Guys, look how perfect that line is. Oh my gosh. You can see I'm not even using a ruler. Oh my gosh, I'm so good at this. Okay, the diagonals bisect at, or intersect at B. So it says the measure of angle rho is 130. So this whole thing is 130 degrees. It says find the measures of all the missing angles. Okay, well, we know these guys are all 90. It's an easy place to start. I know this is also 130. So I can fill that in. I mean, we also know these would both be 65 and 65. Now, we know that this angle, angle O and angle R, they're going to be 50 degrees because they have to add up to 180 with the 130. And then again, we know that they're bisected, so that would be 25 and 25. 25 and 25. And there's all of our missing angles. Pretty proud of that diagram right there, not gonna lie. Okay, let's move on to number 6 here. Sing is a rhombus. Find the values of x and y. Whew. All right. Well, I know you can figure out y for sure. Solving for x would probably be like a bonus question if I had this on like a test or something. It would be like extra credit because it's going to involve some Algebra 2 skills to solve for x. So if you've had Algebra 2 already, and I know some of you have, again, you could pause the video, see if you can figure it out. It's just like a puzzle, and I love puzzles. If you haven't done Algebra 2, I know you could at least figure out the y, and then you can watch and then see if, the x makes sense to you at all. Okay, so let's see. I know this is... Okay, well, we only have to solve for x and y, so I just got to start filling stuff in. 42, 42, right angles. So these are going to add up to 180, so this is 48, meaning that y is 48 degrees. Boom, done. We're done with y. All right, now for the x. Oh, this is so exciting. Okay, well, what do we know about the sides of a rhombus? We know that they are all congruent. So if I'm solving for x, I need an equation, right? So I can start with x squared minus 40 equals 3x. Okay. Now, you might have covered this in Algebra. Yes, I think you would have covered this in Algebra 1. At least knowing that if you have an x squared, that makes it a quadratic equation. Okay, meaning there's going to be two possible answers for x. Now, again, if you've had Algebra 2, you know that there are a lot of different ways to solve a quadratic equation. Maybe the quadratic formula is coming to your mind, which you could use. You could complete the square. You can also solve by factoring. And that's what I'm going to use here to solve this quadratic equation. If you remember the other methods or you prefer the other methods, of course, just, use whatever method you would want. But if I'm going to factor this equation, I need to have all of my x values on one side of the equation, and I'm going to have a 0 on the other side. So I subtract my 3x from both sides. I can't combine the x squared and the 3x because they're not like terms. But that gives me x squared minus 3x minus 40 equals 0. Okay? Now, Algebra 1, peeps, which is all of you, you've all had Algebra 1, you covered factoring, okay? It might not have been your favorite unit, but you did it, and hopefully you can remember it. So when we are factoring a quadratic equation, we want to find two numbers that multiply to -40 and add to -3. So I know some of you out there, you're like Speedy Gonzalez when it comes to numbers and like mental math, and you're like on it. You already got your factors and you're good to go. But for some of you, you might have like a process that you use to come up with factors, depending on what Algebra 1 teacher you had. I'm not going to worry about the whole process right now, but I know my factors are 8 and 5, and if they're going to add to give me a -3, it's going to have to be x minus 8 and x plus 5. Okay? So here's where your Algebra 1 skills come in. If I know that these two factors equal 0, they multiply together to equal 0, I can use the zero product property, and I can split this up to make two equations, right? If I have two things that multiply to 0, that means that forces one of those factors has to be 0. That's the only way you can get 0 when you're multiplying two numbers, right? So I know that either x minus 8 equals 0 or x plus 5 equals 0. Now remember I said with the x squared term here, that means I have two possible answers for x. Well, here they are. X is either going to equal 8 or x is going to equal -5, okay? Now, in the algebraic world, like both of these answers work algebraically. When we apply them back to our original problem of the rhombus, like which answer actually makes sense here? If x was -5, that means this side would be -15, and that does not make any sense. So that means our real answer here would be x equals 8. Okay, so look at that. Some Algebra 2 showing up in geometry. Good stuff. We love it. I hope you learned something. Thanks for watching.